this is a lesson, just to recap, waves, one of the topics we did earlier on in the year. So what I'd like you to do for the first 5 minutes is just write down as much as you can remember about waves. Whatever it is, you've just got 5 minutes. So pause the video and I will carry on when you restart it. Okay. Well, look at the basics of a transverse wave and longitudinal wave, and then your task as a lesson is to return to me via Teams a paragraph explaining the difference between two types of wave, transverse and. Now, these are the key words that you will be able to talk about at the end of the PowerPoint. Transverse, longitudinal, wavelength, frequency, amplitude. They're key words for this lesson. Now, it's important you remember that what waves actually do, they transfer energy and information from one place to another. They don't transfer matter, which is stuff, science word name for stuff. So they don't transfer anything. If you think about a wave, cork just bobs up and down. It's only energy transferring through the water. Water is not moving. Now, let's just recap transverse waves. Now, this is a transverse wave. It's a wave that goes up and down, as you can see by the diagram. And in this case, the wave is moving from left to right. In this situation, if we think about a water wave, particles are moving up and down this direction. So remember, transverse waves have oscillations or vibrations perpendicular. So the wave motion is this way. Perpendicular means at 90 degrees this way, so the direction of motion. So when you talk about transverse waves, that bit there is crucial. Don't say to, you won't get the mark. If you don't use the word perpendicular, you won't get the mark. If you don't talk about oscillations, you won't get the mark. So it's really, really important. Now, examples of transverse waves are light waves, in fact, all of the electromagnetic spectrum, water waves, waves on a string that you're moving up and down, that I showed in lesson, and secondary waves produced by an earthquake. Okay, so just take a moment to have a look at that. I'll pause it and then we'll move on. Now, longitudinal waves, they're slightly different. We still have oscillations, but the oscillations are parallel or in the same direction to the direction of motion. So this wave is moving this way and the oscillations are moving the same direction. Say they're parallel to it. Okay, now compression. So forward, the slinky was compressed, so this is what we call a compression. And when the slinky is expanded, it's called a rarefaction. Now, examples of longitudinal waves are sound waves and the primary waves produced by an earthquake. And again, this bit here, longitudinal waves have oscillations, which are parallel to the direction of motion. Those three things there are key to your explanation. So really, really important. So just take a minute to have a look, press pause, and then we'll move on. Now, we also classify electromagnetic. Now, mechanical waves, these are the where the vibrations move through a medium, a fancy word for the sound waves are moving through the air being the medium in this case. Electromagnetic waves, they don't need a medium to travel through. So, for example, light travels from the sun through vacuum where there's nothing, so that's no medium, so electromagnetic waves can pass through a vacuum, i.e. nothing. Okay. Now, what I'd like you to do is write a sentence to describe the difference between mechanical and electromagnetic waves. If you finish that quite easily, name some, search those, or remember what we've done. But I'll just to give yourselves about 5 minutes on pause to have a go at this task. So I'll see you soon. Right, now have a look what you've got. A substance, and you could have said like water, okay, a string, And then electromagnetic waves, though, don't need anything to pass through. For example, light travels through vacuum of space from the sun to us. So, quick summary: mechanical waves, they're vibrations that travel through a substance and medium. Electromagnetic waves, they don't need anything to pass through, so they can pass through a vacuum. Longitudinal oscillations are parallel to the direction of the wave motion, and transverse waves, the vibrations or oscillations, particular to the direction the wave travels. Really important summary. These 5 statements, which are true and which are false, and the false one's correct. So you can give yourselves 5 minutes for this. So pause it, have a go at it for 5 minutes, and then we'll see how you got on. Okay, so here are the true statements and the change. So just see how you got on and give yourselves a tick or correct anything you didn't get right. So I'll just give yourselves 5 minutes to check it. Well done, hope you did well there. The thing you need to be able to do is label transverse wave. And remember, right at the beginning of this lesson, we talked about some keywords: wavelength, frequency, and amplitude. The wavelength is the distance between 2 same points on a wave. So here we've got from peak to peak, or it could equally be down here from trough to trough if we had got enough trough there, or it could be from this point here where it crosses the axis here and here. They're all the, and remember, it's a length. Is how many complete waves pass a point in a second and measure in hertz. So this is one complete wave, so just follow my laser point up. So that would be one complete wave. So for the frequencies, how many complete waves pass a point? So if we stood here and counted how many of these were passing us in 1 second, that would be its frequency. And then last one, wave from the reference point here, or the 0 line, from there to there. Now, if you're ever asked to label a diagram, you must be really careful to draw it touching there and there in case of wavelength, or there and there in case of amplitude. Just draw from here to here, you won't get the mark, so be really, really careful. So, your task. I would like you to look at this diagram. You've got A, B, C, D, and E. And then I want you to do a little sketch, or just on your books or whatever you've got, have a go at this task. So give yourselves a few minutes, and I'll return. Finally, we've got a match and definition task. So here we've got the definitions. Just pause the video and match them up for me. Okay, so just see what you've got. So waves. The waves are, they transfer energy from one place to another without needing particles or matter. Wavelength is the distance from peak to peak or trough to trough, or the same place on the wave. The frequency is the number of waves per second. And finally, amplitude is the height of the wave above the 0 line. So hopefully you got all 4 of those right. And then moving on to your task, I want you to write a paragraph that compares longitudinal and transverse waves. So you must include all the keywords that we've talked about today. And good luck. I look forward to reading your work. Thank you.